Okay. Good afternoon, all of you. Uh, in the earlier class, we had discussed about the alignment and the location survey. Today, I will discuss about the permanent way. After alignment and location survey, the one of the important part is the permanent way. Okay, permanent way or track, same thing is the railroad on which trains run. When we are talking about the permanent way, so it is important the what are the components of a permanent way. As you can see in this PPT, one figure is there. This is a very common figure of permanent way components for railway. In this figure, you can see the gauge, rail, sleeper, then bearing plate, ballast, formation. These components are present in the figure. Uh, so in our yes,
What is ballast?
I am coming.
Okay, sir.
Acha, Ashina, I have sent all of you the send mail, so I will not consider anything from outside today. Okay, only through mail you can join. So, uh, permanent way component in the permanent way components, the main components are rail, ballast, formation, sleeper. These are the main components. What is rail? Rails rails are the members of the track laid in two parallel lines to provide an unchanging, continuous, and level surface for the movement of trains. To be able to withstand stresses, they are made of high carbon steel. Okay, they're made of high carbon steel, and this rail should be resilience, and this is normally the your I section, rolled I section, and act as a girder because it is taking all the load of the train. So the function of the rail is very important in railway engineering or for our construction because all the load of the train will carry these rail sections. Now another thing that is sleeper. Sleepers are the transverse ties that are laid to support the rails. They have an important role in the track as they transmit the wheel load from the rails to the ballast. Several types of sleepers are used on Indian railways. Okay, so as you can see, this is the figure of rail and sleepers. This is the longitudinal rail, and these are the sleepers transverse in the transverse direction. These are the sleepers, which is transferring the load to the formation level to the ballast or to the formation. And subgrade and formation. Before subgrade and formation, what is ballast? Ballast is a layer of broken stones, gravel, muram, or any other granular material placed and packed below and around sleepers for distributing load from the sleepers to the formation. It provides drainage as well as longitudinal and lateral stability to the track. In this figure, if this is ballast, in reality, uh, if we see in the track side, this is the ballast. Okay, these broken stones, this maybe muram, maybe igneous rock, okay, crushing stone, these are the important material for ballast, which transfer the loads in the ground as well as it helps to drainage. And subgradient formation. What is subgradient formation? Subgrade is the naturally occurring soil which is prepared to receive the ballast. This is actually below the ballast, the formation is there, and this subgrade is naturally occurring in soil, and the prepared flat surface which is ready to receive the ballast along with slippers and rails is called the formation. Okay, the formation is an important constituent of the track as it supports the entire track structure. Ashish Anand. Okay. Uh, Now, the what is the permanent way? Actually, details of the permanent way we need to know. Track or permanent way, obviously, it is a railroad on which trains run, but it consists of two parallel rails fastened to sleepers with specified distance between them, and the sleepers are embedded in a layer of ballast of specified thickness spread over level ground known as formation. The ballast provides a uniform level surface and drainage and transfers the load to a drainage area of the formation. Okay, the rails are joined in series by fish plates and bolts, and these are fastened to the sleepers with various types of fittings. Now, one thing is fish plate, bolts. We will come details, but this is our fish plate actually in railway to joining two rails. It is used to joining two rails, fish plates, bolts, uh, clips, various clips. We'll study. Slowly will all the things will come, but for the time being, if we say what is the fish plate, this is the fish plate. Fish plate means not the uh, machli plate, huh? Okay, so fish plate is the in railway engineering, it is used to join two rail lines, and these fish plates these rails are joined in series by fish plates and bolts, and these are fastened to the sleepers with various types of fittings. The sleepers are spaced at a specified distance and are held in position by the ballast. Each component of the track has a specified function to perform. The rails act as girders to transmit the wheel load of trains to the sleepers. The sleepers hold the rails in their proper positions, provide a correct gauge with the help of fittings and fastenings, and transfer the load to the ballast. The formation takes the total load of the track as well as of the train moving on it. Achha, the permanent way of track therefore consists of the rails, sleepers, fittings, and fastenings, the ballast, and the formation. You can see all the components in this figure. This is the schematic diagram of the permanent way. Okay, and it is very important for broad question or for permanent way components. This is the first question in core railway engineering. What are the components of permanent way? Or you may ask to draw this figure. So you can draw if you have pen or copy with you. You can draw. Otherwise, I will give you. In the early days, a temporary track used to be laid for carrying earth and other building materials for the construction of the railway line. This temporary track used to be removed subsequently. The track is also called the permanent way in order to distinguish the final track constructed for the movement of trains from the temporary track constructed to carry building materials. And the specification adopted by Indian Railways for various types of railway tracks are discussed uh, slowly. We will discuss, and for this permanent way, another thing which is required, that is requirements of good permanent way. Here are some points about the requirement of good permanence way. First, the gauge should be correct and uniform. The gauge will come about the gauge in the next class. Okay, gauge also one of the part of syllabus in railway engineering syllabus, which is important, but details about the gauge will come next class. The gauge should be correct, and we know the gauges: broad gauge, meter gauge, and narrow gauge. The gauge should be correct and uniform. The rail should have perfect cross levels in curves. The outer rail should have proper super elevation to take into account the centrifugal force. The alignment should be straight and free of kinks. Kinks means the twisting of railway. In curve section during construction or during movement of the train, it is highly possible for these kinks in the railway section, in the railway lines, in the twisting. In the case of curves, a proper transition should be provided between the straight track and the curve. The alignment should be straight and free of the gradient should be uniform, as gentle as possible. The change of gradient should be followed by a proper vertical curve to provide a smooth ride. Okay. The track should be resilient, that is permanent, should be stable and elastic in order to absorb the shocks and vibrations of running trains. There is highly dynamic load is there, so the track should be like shock absorber. It should take all the dynamic loads from the moving train. The track should have good drainage system so that the stability of the track is not affected by waterlogging. So for that purpose we have to put, or we have to provide a good ballast on the formation. The track should have good lateral strength so that it can maintain its stability despite variations in temperature and other such factors. There should be provisions for easy replacement and renewal of the various track components. The track should have such a structure that not only is its initial cost low, but also its maintenance cost is minimum. So last 2 points, you can see that there should be a provisions for easy replacement and renewal of the previous track component, because the durability of one track is more than 3 to 4 years, not more than 3 to 4 years. After 3 to 4 years, for railway authorities, they have to change the tracks, so there should be a easy way to renewal and easy way to replacement. The track should have such structure that not only its initial cost low, but also its maintenance cost is minimum. And after these requirements, the component permanent way components and the various components: rail, sleeper, ballast, subgrade, formation, ballast, fish plates, and the requirements of good permanent way. The track specification on Indian Railways. This is very important. You can note down the points. Track specification on Indian Railways. Very important informations are there. Formation of 6.85 meter wide. Formation means this is formation. This is formation. You can see this in this figure. This is formation. The formation of 6.85 meter wide for broad gauge and 5.85 meter wide for meter gauge. This track specification specially given for always for broad gauge and meter gauge. For narrow gauge, these specifications are changed on the basis of the condition situation. So all the specifications of Indian railways track specifications are given for broad gauge and meter gauge. Maximum specifications are given for broad gauge and meter gauge, but for narrow gauge special conditions are applied. Most of the track is straight except for 16% of the track on broad gauge and meter gauge, and 20% of the track on narrow gauge, which are on curves. The maximum degree of curvature permissible is 10 inch on broad gauge and 16 inch on meter gauge and 40 inch on narrow gauge, the maximum degree of curvature. The ballast used most is the broken stone ballast, but in some areas sand, muram and coal ashes have also been used. Uh, then about 20 centimeter to 30 centimeter. Hello, hello. কম আমি একটু বিজি আছি, বিজি আছি সরি। আচ্ছা, about a 20 centimeter to 30 centimeter cushion of ballast is normally given below the bottom of sleepers to transfer the load evenly and to give necessary resilience to the track. Okay, these values, the specification values are very important because it is these specification values are provided for Indian Railways for their track. The different types of sleepers used for broad gauge are pre-stressed concrete, uh, pre-stressed concrete sleepers about 94 to 94.2%, cast iron sleepers 4%, steel sleepers 1.5%, and wooden sleepers 0.3%. These are the different types of sleepers which are used for broad gauge line. Similar figures for different types of sleepers for meter gauge and the sleepers are PSC sleepers. For meter gauge, PSC sleepers are 9.8%, steel sleepers are 14.7%, cast iron sleepers 69%, and wooden sleepers 6.5%. Pre-stressed concrete sleepers have been developed by Indian Railways. As you know, the sleepers now all the sleepers are pre-stressed concrete made from pre-stressed concrete and are being progressively laid on Group A and B routes. We will come what is Group A and Group B routes. Sleepers are laid to various sleeper densities varying from M plus 8 to M plus 4. Sleeper density is there. Again, there are number of problems regarding sleeper densities. We will practice here. And you will give some assignment from about this sleeper densities. But after some classes, it will start. Depending upon the weight and volume traffic. So sleepers are laid to various sleeper densities varying from M plus 8 to M plus 4. That means 1660 per kilometer to 1310 per kilometer, depending upon the weight and volume of traffic. Not only sleepers, the rail standardized for Indian Railways are 60 kg and 52 kg and 90R, 75R and 60R for meter gauge. Acha, the rail standardized, the weight of the one single rail for broad gauge 60 kg. Two specifications are there for broad gauge. One is 60 kg and another is 52 kg. And for meter gauge, this specification changed to 90R, 75R and 60R for meter gauge. About this specification we'll discuss when the specification part, actual specification part of the rail will come. Then we'll discuss what is this 90R, what is this 75R, what is this 60R. Okay. The rails are normally rolled in 13-meter lengths for broad gauge and 12-meter lengths for meter gauge. So the length of a single rail, that is 13 meter, and for broad gauge, and 12-meter length for meter gauge. Rails are welded together to form longer rails, and these are laid progressively in the track in order to reduce maintenance cost and noise level and providing a more comfortable travel. The rails LWR. LWR means long welded rails. Okay, long welded rails are welded in three rail panels in depots, normally by flash butt welding. Flash butt welding. I think you had the welding in your first year workshop. So the you should know the what is flash butt welding. By the flash butt welding method to form short welded rails. So the rails long welding rail are welded in three rail panels in depots, normally by the flash butt welding method to form short welded rails. And long welded rails are also being progressively introduced on various routes of Indian railways. Now, thermite welding. Thermite welding is normally done at the site to convert short welded rail to into long welded rail. Okay, though there is two type of welding, one is flash butt, another is thermite. The fastenings used are mostly screw and rail spikes, keys, etc. But recently elastic fastenings like elastic clips, pendrol clip, one of the important and one of the common name pendrol clip. This is pendrol clip. Sorry, this is pendrol clip. This you can see. This is the pendrol clip. This which is used to fastening the rail line. This but recently elastic fastening like elastic clips, pendrol clips, and IRN 2002 clips have also been standardized on Indian railways. Same things uh, regarding clip and these rail lines we will come after 1 and 2 class. Okay, gradually we will cover all the things. Next, after this railway specifications, there is recommended track structure for broad gauge and meter gauge roads. Under this recommended track structure, classification of you should know the classification of railway lines in India. First, for broad gauge routes, there is Group A lines, Group B lines, Group C lines, Group D and D special lines, Group E and E special lines. Okay, what are the Group A lines? Acha, the actually why we are called this is Group A line. Group A lines are meant for a sanctioned speed of 160 km per hour, like New Delhi to Howrah by Rajdhani route, New Delhi to Mumbai Central by Frontier Mail Rajdhani route, New Delhi to Chennai Central by Grand Trunk route, Howrah, Mumbai, VT via Nagpur. These are the Group A lines, and maximum speed, sanction speed is 160 km per hour. Okay. Then Group B lines. Group B lines are meant for sanction speed of 130 km per hour. Okay. Prayagraj, Itarsi, Bhusbal, Kallan, Wadi, Raichur, Madras, Kharagpur, Walter, Vijayawada, Wadi, Secunderabad, Kajipet, Howrah, Bandel, Bardhaman, Barhava, over Farakka, Malda town, Barsoi, New Jalpaiguri, Sitarampur, Kiul, Patna, Mughalsarai, Kiul, Sahibganj, Barhanva, Delhi, Ambala, Kant, Kalka, Amla Kant, Ludhiana, Pathankot, Ambala Kant, Moradabad, Lucknow, Pratapgarh, Mughalsarai, Arakonam, Erode, Coimbatore, Bhadodara, Ahmedabad, Jalapet, Bangalore, and Group C lines. Group C lines are meant for suburban sections of Mumbai, Kolkata, and Delhi. Group D and Group D special lines. Group D lines are meant for sections where yes,
सर
yeah. Huh.
सर थोड़ा जूम कीजिए ना.
Oh, Zoom. Wait.
Yes, sir.
Wait. Hmm. Now it is visible.
थोड़ा जूम कम कर दीजिए नहीं
हाँ.
तो जो साइड में है वो नहीं दिख.
ओके, एक मिनट रुक जाओ. वेट. think this is not visible. This portion is not visible. Group B line. Group B lines are not visible, I think. No. First, see what are the Group A lines, and then what are the Group B lines. These are the Group B lines. Okay. Group B lines are meant for sanctioned speed of 130 km per hour, and the Prayagraj, Itarsi, Pursuval 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 routes are there under Group B lines, and the sanction speed for the Group B lines are 130 km per hour. Okay. Next, Group C lines. Okay. Group C lines. Group C lines are meant for suburban sections of Mumbai, Kolkata, Delhi. And Group D and D special lines. Group D lines are meant for sections where the maximum sanction speed is 100 km per hour. 100 km per hour. And Group E special. Group E and Group E special lines. These lines are meant for other sections and branch lines. Achha. The D special and E special routes, based on the importance of routes, it has been decided that few selected routes currently falling under D and E routes will be classified as D special and E special routes. So Group A, Group B, Group C, Group D special, Group E special. These are the main classifications of railway lines in India under broad gauge route. Next, meter gauge. Meter gauge routes. Wait. Okay, recommended track structure for meter gauge routes. Okay, meter gauge routes in Indian Railway. Q routes with a maximum permissible speed of more than 75 km per hour. Traffic density is generally more than 2.5 GMT, gross million ton per kilometer per annum. GMT is the gross million ton per kilometer per annum. R routes with a speed potential of 75 km per hour and a traffic density of more than 1.5 GMT, gross million tons per kilometer per annum. R routes have further been classified into three categories depending upon the volume of traffic: R1, R2 and R3. R1 traffic density more than 5 GMT, R2 traffic density between 2.5 and 5 GMT, R3 traffic density between 1.5 and 2.5 GMT. S routes with a speed potential of less than 75 km per hour and a traffic density of less than 1.5 GMT consist of routes that are not covered in Q, R1, R2 and R3 routes. S routes have been further subclassified in three routes, namely S1, S2 and S3. S1 routes are used for through movement of freight traffic. Freight traffic means good trains. S2 routes are those which are neither in S1 or S3, and S3 routes are uneconomical branch lines. Okay, these are the routes under meter gauge routes. Classification of broad gauge routes, classification of meter gauge routes. Under meter gauge routes, Q routes, R routes, further R1, R2, R3 and S routes, and further S1, S2, S3. One is Q routes, which is more than 75 km per hour, R routes, which is potential of 75 km, and S route less than 75 km. After this classification, you should know about the maintenance, and this the maintenance of permanent way. The maintenance, acha. Another thing under this recommended track structure for broad gauge and meter gauge, that is the you should know the some things, that is the Indian Railways has modernized its track structure in the recent past to meet the challenges of heavier loads and faster traffic. More than 10,000 km of the track is laid with 60 kg rails, and more than 40,000 km is laid with concrete sleepers. This value should keep in your mind, that is more than 10,000 km of the track is laid with 60 kg rails, and more than 40,000 km is laid with concrete sleepers. The current Indian Railway standards for broad gauge and meter gauge routes are elaborated. Uh, the track structure for broad gauge route, the tracks on Indian Railways broad gauge section is classified into 5 broad categories based on speed. These are group A, B, C, D. Already and E routes already we have seen. Additionally, D special and E special routes have been subsequently added. The track standard on broad gauge routes has been reviewed and revised from time to time based on the obtainable speeds and traffic condition. The current broad gauge track structure, you can see heard about the bullet trains, fast trains, like these trains are now available in India. Bande Bharat Express, some express are there. So time to time, requirements of the people, requirements of the all the based on the situation, the speed has been modified, and the also tracks have been modified due to these situations, and based on the requirements of the people of India. And after this recommended track structure for broad gauge and meter gauge, uh, also tracks for on meter gauge routes have been classified based on speed and gross million tons in categories Q, R1, R2, R3, and S routes. The S route of meter gauge has been further classified as S1, S2, S3 routes. And after that, we need the what are the maintenance of, or what is the maintenance of permanent way. Permanent way is the backbone of any railway system, and the safety and comfort of the traveling public preliminary rest on its proper maintenance. Till a decade ago, the tracks on Indian railways were mostly manually maintained by better packing as per a fixed timetable round the year. In recent years, however, on account of heavier and faster traffic and due to economic considerations, modern methods of track maintenance such as measured shovel packing, mechanized maintenance, and directed track maintenance have been tried and are in vogue in some sections of Indian railways, particularly on high-speed routes. Mechanical maintenance of the track has been introduced on about 14,500 km of high density broad gauge routes, and the rest of the track is maintained through manual labor. The labor force directly employed for this task is about 19,000. Today, about 3,000 km of track is being maintained by measured shovel packing, which is an improved method of manual packing. A need-based directed track maintenance system which initiates maintenance work only when there is actual requirement is being increasingly introduced in order to eliminate unnecessary maintenance work. Okay. It makes the labor force more productive. About 20,000 km of track is covered by this system. A major portion of the track, however, continues to be maintained on a predetermined cyclic program by the manual method of maintenance, that is bitter packaging. The full details of these methods of maintenance will be discussed. And track utilization under this maintenance of permanent way. Maintenance is the one information. Maintenance of permanent way is the information. Just I am telling this information to you. In 1888, someone propounded the theory that track is an elastic structure. Sorry, track utilization. Track utilization is the with introduction of highway capacity boggy wagons and the replacement of steam locomotives with more powerful diesel and electric locomotives, the tracks have been subjected to heavier axle loads and higher operating speeds. During the period 1950 to 51 to 1994 to 95, the average density of traffic in terms of the net million tons kilometer per route kilometer has increased from 5.24 to 18.4 millions on broad gauge and from 1.19 to 2.65 millions on meter gauge. The increased track loading has necessitated improvement in the track structure and maintenance practices, especially over high density and high speed routes. So track utilization also one information which I have told you. After this requirement maintenance of the permanent way, one part that is, sorry, I have written here wrong. This is the coning of wheel. Coning of wheels. Coning of wheels. Coning of wheels. This is one of the important part. If we consider one figure for permanent way components, then another figure for coning of wheels. The tread of the wheels of a railway vehicle is not made flat but sloped like a cone. Okay. In order to enable the vehicle to move smoothly on curves as well as on straight tracks, the wheels are generally centrally aligned on a straight and level surface with uniform gauge, and the circumference of the treads of the inner and outer wheels are equal, as can you see in this figure. The problem, however, arises in the case of curve, when our wheel with train in the curve section, then the problem is arised. The problem, however, arises in the case of of a car when the outer wheel has to negotiate more distance on the car as compared to the inner wheel. When when train with wheel on a car, then one wheel is in inner side and another wheel in a outer side, at outer side. So at that condition, the outer wheel has to negotiate more distance on the car as compared to the inner wheel. Due to the action of centrifugal force on a car, the vehicle tends to move out. Obviously, on car there is centrifugal force, as we know from our highway engineering. The vehicle tends to move out. To avoid this, the circumference of the tread of the outer wheel is made greater than that of inner wheel. This helps the outer wheel to travel a longer distance than the inner wheel. The wheels of a railway vehicle are connected by an axle which is fixed on a rigid frame. this is the axle. Due to the rigidity of the frame, the rear axle has a tendency to move inward. Okay, there are number of axles. So the rear axle has a tendency to move inward, which does not permit the leading axle, the front axle, to the take full advantage of the coning. And the rigidity of the frame, however, helps to bring the vehicle back into the central alignment and thus work as a balancing factor. The coning of wheels also helps to keep the vehicle centrally aligned on a straight and level track. Slight irregularities in the track do occur as a result of moving loads uh, and the vagaries of the weather. The wheels therefore move from side to side and therefore the vehicles sway. Sway is the movement in the if train in longitudinal direction. Sway is the movement of lateral direction. Sway is the movement of the lateral direction. Due to the coning of wheels, these side movements results in the tread circumference of one wheel increasing over the other, as both the wheels have to transverse the same distance. This causes one wheel to slide. Due to the resistance caused by the sliding, any further side movement is prevented. If there is no coning, the side movement would have continued and the flange of the wheel would have come in contact with the side of the rail. This is the flange. This portion, this darkened portion is the flange. Okay. And the flange of the wheel would have come into contact with the side of the rail, causing jars and make the ride uncomfortable. Coning of the wheel causes wear and tear due to the slipping action. It is slipping, same as slipping. Slipping is the shipment, same as like highway engineering. It is, however, useful the following ways. One is it helps the vehicle to negotiate a curve smoothly. It provides a smooth ride. It reduces the wear and tear of the wheel flanges. Okay, this is actually purpose of the cone. Normally this slope is maintained 1 in 20, and also you can see here our formation level. The so sorry, no, sorry, no formation level. Our rail line also placed in a slope, placed with a slope 1 in 20. Not only our this wheel in a slope shape, the slope is 1 is 20. In rail section also the slope is 1 in 20. Okay, finally the summary of the permanent way component, or about the permanent way. The permanent way consists of rails, sleepers, the ballast, sleeper fittings, and the subgrade. The strength of each of these components is essential for the safe running of trains. The stresses developed in each component due to the movement of wheel loads should be within permissible limits as specified for different types of tracks. The coning of wheels helps reduce the wear and tear of the wheel flanges, providing a smooth ride. The ill effects of coning on horizontal curves are reduced by laying the rails at a slope of 1 in 20. Laying of the rails at is normally maintained a slope of 1 in 20. After today's class, I'll send one quiz to all of you. By today, you should give me back after solution. Simply Google quiz I'll send you, no problem. But you should give me by today. So today's class, I think I should stop. If you have any question, please tell me. any question bolo
Will you send this one?
this I will send this ppt yeah.
Okay, sir. Thank you, sir.
Any other any question acha just let me see yeah bolo
স্যার ফোল্ডিং অফ রেলের যে ব্যাপারটা বললেন না স্যার, ইনার ডায়ার আউটার ডায়ার মধ্যে যে ব্যাপারটা স্যার, ওটা একবার বলবেন?
সিম্পলি এখানে দাঁড়াও আমি বলছি এক মিনিট প্লিজ রেসপন্স ইউর নেমস আদিল অভিষেক মন্ডল, অজয় কুমার, আকাশ গড়াই, अमन राज, अमित राज, अंकुर साहा, अरविंद माहातो, हाँ अरिजित मंडल, अर्पिता भट्टाचार्य, आशीष आनंद, आतिकुल सानी, अभ्र दत्त, अयन बारिक, दिब्या कुमारी, दुर्लभ गड़ाई, किशलय कश्यप, कृष्णचंद्र, कुमार दीपेश, कुमार सोम, मनीष माहातो, एमडी साहिल, निरुपम सेन, प्रियंका घोष, प्रियो हाँ प्रेजेंट प्रियो फौजदार अच्छा रहमत राजा बयरा शुभ दत्त ठीक है ओके हाँ हाँ ओके अच्छा हाँ ओके लिसन अच्छा ओके anyone please send me the Aman's WhatsApp number your CR ना Aman CR है ना okay okay thank you you can leave